Again from NDB, it's another picture-based question. Let's read the question first. An aircraft has an RMI, again RMI with 2 needles. So this one dial with 2 needles. Yep. Assume that the aircraft is outbound from NDB Y on a track of 126-degree magnetic with a drift of 14 degrees port, and a position report is required when crossing a QDR of 22 degrees now from another NDB, which is NDB Z. And you again have 4 different indications here. Let's find out. I'll give you time again, come back and we'll do it together. Alright, so let's see the question once again. Here we have 2 different assumptions which we need to make. Number 1 is that the aircraft is outbound from an NDB Y on a track of 126 degrees magnetic. So this is the track from the NDB, so it's more like the QDR, right? From the NDB is 126, it's in magnetic, and the drift is given as 14 degrees port. Remember, port drift means your track is to the left of heading, and therefore 126 being your track, and you're going outbound, your heading is 126 plus 14, that is 140 degrees heading. We have another NDB, that is NDB Z, and you're supposed to report when you cross the QDR of 22 degrees. So QDR is basically the magnetic track now from the NDB Z. So when you cross the 22 degrees track from the NDB, if it was a VOR, we could have probably called it as a radial, but here it is the NDB, so it's more appropriately called as the QDR, the track, magnetic track from the station of 22 degrees. As you cross it, you're supposed to give a report. Looking at 2 different NDBs here, 1 RMI indication, RMI dial with 2 different needles. All right, so what we're going to do here is kind of depict the very first part of it and then kind of impose the second assumption into it. It's an RMI, radiomatic indicator, therefore the head of the RMI is definitely the heading of the aircraft. So all the basic information are right here, and we have the options in the form of the 3 or the 4 indications. You're supposed to pick up the right indication showing both these assumptions correct. Let's go to this question. Let's kind of start drawing. So it's question number 10 here. You have 2 different NDBs. The first one is NDB Y, and the track outbound from the NDB. It's a magnetic track, and therefore the QDR from the NDB is 126 degrees magnetic with a drift correction of 14 degrees port. So we know that when you track outbound, tracking outbound with 14 degree port drift, your RBI is possibly going to read 180 minus 14 degrees. That's going to be your RBI indication. What is the RMI indicating? RMI is basically indicating the magnetic track to the station, right? So magnetic track, that's the first point to understand here. Second is not from, it is to. The third point is to what? To the NDB, to the station, right? And this is what we Q code as QDM. So what we have is a QDR, which is the magnetic track from the station. How will you find out QDM? It's just a reciprocal of that, right? So it is 126 degrees plus 180 degrees, and that's going to amount to 306 degrees magnetic is the track to the station. Right? Let's kind of now draw this. So we have an NDB from where the aircraft is tracking 126 outbound, right? So let's draw the NDB here. Perfect. Now this is your NDB Y. We're looking at question number 10 here. So NDB Y, you're tracking outbound from the NDB on a QDR of 126. It's not the exact representation of the angles, as you would know. So this is 126 degrees magnetic outbound, and that is what is the QTR from the station, right? The aircraft is having 14 degree port drift moving outbound. You have a track of 126 degrees, and with 14 degrees of port drift, what you can derive is the magnetic heading. Since it's a port drift, your heading is always going to be 126 plus 14. And that's going to be 140 140 degrees. Remember, for RMI indications, your heading is a critical element in picking up the answer, because the head of the RMI indication is the heading itself. In case of RBI, it doesn't quite matter as far as getting the options correct, because the RBI indication is independent of your heading, and the head of the RBI is 0 rather than the exact heading. So 140 is the heading of the aircraft. Now, why we need the heading at this moment is to place the aircraft properly on this track of 126. So track of 126, let's draw the aircraft. The heading of the aircraft is 140, so the nose is going to be right of the track, and that is why we say we have a port drift. All right, let me kind of just push it a bit down here. All right, this is a heading of 140 degrees, and obviously you can see that there is a port drift measured from the heading to the track, and it's left of heading, that's why it's port drift of 14 degrees. Perfect. Let's see the RMI indication. This is the assumption alpha, right? So what we have just drawn here is your assumption alpha, that part of it, right? Let's now kind of draw the RMI indication with this assumption alpha, right? To draw the RMI indication, it's always recommended to draw a dial around the aircraft. That's it, perfect. As you know, the ADF needle is least bothered about which direction you're traveling. It only points towards the NDB, to which it's locked on, right? So the aircraft is here, and now let's draw the. Let me kind of reposition the aircraft a bit. All right, perfect. So we have 14 degrees of port drift. Got dropped off. Sorry. Yeah, that's right. That's right. I'll get back to answers again. Let's draw the indication. The ADF is going to tell you. The ADF needle is going to simply point towards the NDB. So that's right here. So I'm just playing around with the colors just to make it more prominent on your screen share. All right. So what is this? This is basically the QDM, and that is what we just found out as 306 degrees. So basically, 306 degrees is the RMI indication. That should be the RMI indication towards the NDBY. Now, along with this, bring the assumption B into practice. So basically, we are looking at 306 RMI indication here. For assumption alpha. Let's look at assumption Bravo, where you are asked to report when you are crossing a QDR of 22 degrees from, you can see it right here, 22 degrees from NDBZ. So 22 degrees from NDBZ, as rightly they have mentioned, is the QDR, right? Let's look at this 22 degrees track from an NDB and kind of position the NDB in such a way that it is relevant to our aircraft right here. So let's draw a track of 22 degrees that is passing through the aircraft. So 22 degrees is somewhat a line of this sort, roughly. Now this means that the NDB is somewhere in this line, right? This is our NDBZ. And we have assumed this track as 22 degrees, and therefore it is the magnetic track from the station, which is nothing but the QDR. What the ADF, or the RMI, is going to show you is not the QDR, it's going to show you the magnetic track to the station, which is the QDM, right? So for this NDBZ with a QDR of 22 degrees, now it's magnetic. How will you find out the QDM, which is the RMI indication? That is plus 180, it is just a reciprocal, and that's going to be 202 degrees magnetic. Perfect. So what the RMI over here is going to indicate is basically a pointer that is just pointing towards the NDB. It is least bothered about any other factors, but we now know that it will be indicating on the dial a magnetic track of 202 degrees from the aircraft to the station. Right. So basically we are looking at these two RMI indications, one 306 degrees, the other RMI is 202 degrees. So for assumption Bravo, the RMI is going to show you 202 degrees of RMI, and the third part is the heading, which is 140 degrees. So we're looking at three different factors here: the RMI of RMI to NDB A, which is 306, RMI to NDB Z, I'm sorry, it's not A, my bad, it's Y, which is 202 degrees magnetic, and we have a heading which is right here of 140 degrees magnetic. If we can kind of identify an RBI indication from the options which kind of depict all these three values appropriately, that is going to be the answer. Be very careful, not just one, all the three has to satisfy for the answer, for the option to be the answer. All right, before we pick up the answer, let's now draw a dial that would kind of look like depicting these values right here. Look at this figure that we have drawn and look at the dial. This is the beauty of actually drawing the circle around the aircraft and kind of depicting the needles. That's exactly what the pilot would be seeing. Only thing is it's kind of upside down here because now the pilot is traveling down on the page. If you can draw this diagram erect with the nose pointing straight up to 0, then you would probably exactly have the indication very similar to what is given in the option. Let's draw that on the basis of the values which we have here before we pick up the answer. So first thing first, the center of the dial is definitely the aircraft, right here. Now again, as I've told you before, it's a good practice to kind of assume a dial around the aircraft, and this goes with everything for your CDI indications, for your ILS, your localizer indications. It's pretty convenient if you can kind of imagine the dial, especially having the fact that most of you haven't flown an aircraft, and probably even if you have flown, not really to a stage where you can understand all these dials, because it's all part of instrument flight, right? Yes, so the head, this being an ADF RMI, so this is an RMI, the head is going to be the heading, which is 140 degrees magnetic. So out of the options, you have to first look into an option where the heading is 140. Now let's keep that options there a bit enlarged just for you to kind of conveniently compare, but at the moment let's kind of draw this diagram. Heading is 140. Next is the RMI to NDBY is 306 degrees magnetic. Now to have a proper orientation of this, let's look at this the tail of the aircraft. If the head is 140, the tail is going to be 180 degree off from that, which is going to be 140 plus 180, which is 320. This is for us to get a spatial awareness so that we can find out where these 306 and 202 degrees are, right? And from 140, if you take a 90 degrees, that's going to give you 230 degrees. And from 320, if you again count 90 degrees, and that's going to give you 50 degrees. Right, so you can see that the dial kind of rotates in such a way that the heading, the nose of the head of the dial is always the heading of the aircraft. So basically this is the aircraft's heading. Perfect. Now having these all the 4 points kind of fixed, let's kind of fix the required points here. RMI to NDBY is 306 degrees magnetic. Let's kind of position this 306 degrees. So 306 should be somewhere close to 320. So that is 306 degrees. Now that is the first RMI dial. Perfect. The second RMI dial is going to point towards 202 degrees. So let's find out where 202 degrees is. And let's draw the corresponding RMI needle. That's it. So you can see how the diagram should look like. This is how a pilot would see from the cockpit, right? Look at the options here, Alpha, Bravo, Charlie, Delta, and look at the one that is more similar to the one that I've drawn here. Make sure you note where the arrow head is and where the tail is. Don't get confused with that. Look at option Alpha and option Charlie. Option Alpha and option Delta. Both of them seemingly looks like quite similar to the figure that is the one which I have drawn, and more appropriately it's more like alpha, right? Let's look at the figure from an actual value point of view. Look at the heading. First thing to fix is the heading. Out of the 4 figures, you're looking for the figures which have 140 degree as the heading. So let's find out. So over here you can see the heading is somewhere around 130, 140. Perfect. So this is 120 here. Let me just enlarge this a bit for you. All right, so you can see 120, 130 and 140. Yes, the heading is 140 here. That goes in line with what we have. It's pretty obvious here. That's 120 here. It's 130. So it's somewhere between 120 and 130. Let's take it, say 125 degrees. So we can kind of take Bravo out of the picture. Charlie is again 120, 130, 140. You see how it becomes a bit confusing. Now we have two different pictures with the same heading, and now you have to look into the RMI indication straight. And the last one is again pretty obvious that it won't be the answer because it is 90, 100, 110 degrees heading. Therefore delta is also not the answer. Now to find or to fix between alpha and Charlie, we have to now go into various RMI values. The RMI value that we have is 306 degrees and 202 degrees. Let's find out. So over the first alpha, you can see it is let me get a different color for that. Yes, so it is 90 here, 100, 110 degrees. So it's 180 here, 190, 200. So and now let's see what is the RMI towards SZ. This is RMI towards SZ, which you have currently drawn. And RMI towards Y is 306 degrees. This is 300, 310. Yes, this can be 306 degrees. This is the RMI to NDBY. Now let's look at Charlie. So alpha is definitely a very possible answer if Charlie is kind of way different. Heading being the same, let's look at the indication here. That is somewhere around 180, 190, 200. So this could definitely be close to 202, no doubt about it. But what about the RMI to the other one, which is to Y? And it is quite clear that you can see where the arrow head is. And be very, very careful here that this is a tail, so don't conveniently take it as a head because it kind of follows the sequence of most of the other figures down here. The arrowhead identified first, and that's pointing towards 120. So it's basically 120, 130, somewhere around 125, and therefore definitely Charlie is not the answer. Alpha is the answer. We did find out alpha initially, even without looking at all these things, because we got a diagram that is pretty similar to the answer. So compare these two diagrams, the one on the left, which is on the text, and the other which we managed to draw. So this is the alpha, and this is the one that we managed to draw. So you can see how similar that is. So if you can draw it properly and depict the points seemingly like in the right orientation, then you can actually find out the same dialing. All right, that's it. So I hope this question is pretty clear. Again, a picture-based question, very, very interesting question because it's all concept-based, and you should really know how to depict the RMI indication of an ADF. All right, perfect. Yes. Now it is definitely not a wrong thing. In fact, pretty much a good idea to kind of depict the same thing on an RBI. So if you get some time, try depicting the same question on an RBI and see how that works. All right. Yes, perfect. Now let's dive into the next question, which is question number 21. Right, so I'll leave this question completely for you, and we will kind of continue this question after the afternoon break. I know it's not a very difficult question. We have done a couple of questions of the same format, the previous year questions from the exam. But let's look at this particular question from the Oxford, because I would like to detail some additional points regarding quadrantal error. The ADF of an aircraft on a heading of 189 degrees true. So the aircraft on a heading of 189 degrees true will experience the greatest effect due to quadrantal error if the NDB bears. So one of the significant and unique errors of an NDB is the quadrantal error, right? Even though we know that static interference is the one that is having the highest amount of error in an NDB ADF system, this is also significant and a unique, a separate error which none of the other navigation aids have, right? If you look into some of the quadrantal errors which are associated with the celestial navigation system, that's a bit different from this, so don't really get confused with that and the one that we study in under NDB.